Hello, my name is James Anderson, and I'm just going to do a little demo about the work I've been doing with visualizing and analyzing how the Delaunay is actually working. So if you see here, I have the point cloud with the red points. This is a model of an A10. And if I go here, and if I check this, now these are all of the edges that are generated from doing a Delaunay on this particular set of points. And if you see here, you can rotate around here. It pretty much it does what's called it makes a convex hull of all of the points. If you see, there are a lot of points like here on the tip of the nose that are connected up there, like at the edge of the wing. And if I do click on these, you can actually see for this point, you can kind of see there in magenta. For this point, it's actually connected to all of these. So this would mean if you're at this point and you're trying to walk to the next neighbor, it could walk to any one of these blue points. So if the true point was actually over here, this would be a good option because you could take these long paths, or else if it was over here, you'd want to take these small jumps over to, say, if it was over here, you'd have to take a few small jumps to get over here. But say like this point's connected over here. So, let me get back to this, like that, and I will clear that out. So the next thing is, if we have these yellow points, which in this case, they're a direct copy of the red points, and kind of ignore the flashing here. This is because these points are like sitting right on top of each other and they're fighting with who gets to actually be rendered onto the screen. So that's just kind of a weird artifact. But anyway, the yellow points, in our case, those would be from our stereo block matching. But in this case, I just simply made a copy just to demonstrate what's happening here. So if we clicked on one of these points, so what's happening here is this point here in magenta. Let me get whoops. Fight with this thing. There. If you click on it wrong, it doesn't work too well. There we go. So what's happening here is, excuse me, this magenta point is the closest neighbor that the Delaunay traversal has found is this blue point. And in fact, the point that it started at is this green point way back on the tail. As you can see all the walks it's took to get to this point. And that's not the most efficient way if you just started here. So this point may not be the best point to start from. It may be better, in fact, I think we had discussed starting from somewhere in the middle. Another option that we've worked out is to start with an approximate nearest neighbor, in which it will take a KD tree of all of these red points. It will traverse down the KD tree to find the approximate neighbor to this magenta point. And if I click here, you'll see that the approximate neighbor search returns this point. And then starting from this point, we traverse through here to find the actual neighbor point, which is the same if you go this way or if you go this way, you're going to end up at the same point because it ends up just at the closest point. The final thing I have here is, if you look here, right now, this is running for every yellow point, it's finding its corresponding neighbor point in the red cloud. What this is averaging all of those walks. What's the average number of steps that are being taken to find the closest neighbor? If you look here, if we start from this 0 indexed point, here it's 18, and if I kind of rotate the cloud, it's going to change a little bit here and there. It hovers around 20. If I switch over to saying we want to look at it starting at this point, the number goes down quite a bit. As you see, maybe 5 or 6 there. If I rotate around some other axes, it kind of does the same thing. And like that. So then kind of the last thing, let me see if I can clear this out. The last thing here is just to kind of have an overall view of what's happening with the neighbors, to see where what ICP is going to do with the neighbors. We have here all of these kind of purple lines are going to the corresponding neighbors, and as I rotate this around, you can see it. You can see how these points would want to be drawn over to here. These points would want to be drawn back to here. On the wing, they want to be drawn this way and this way. So it really gets you kind of a good idea of what ICP is going to do with these neighbors. And then again, if I take this down, now it's doing the approximate neighbor, so it ends up being a little faster. The frame rate's not doing too bad here. So that is just my demonstration of the Delaunay, the visualization of the edges, the neighbor, the walks, and the visualization of the starting from the 0 and the approximate neighbor. Thank you.